Okay, we are live.
Awesome.
Awesome. Hi everyone, thanks for joining this live stream and those who are watching on YouTube. I am really excited for this live stream. And I feel if you are in AEC tech space, you know Andrew, you know Hyper. Like Andrew needs no introduction. And just to give a background, like he has worked in companies like WeWork and BBJ Woodsberger, and he's also w- and worked at. Oh man, I just started hearing my echo from YouTube. So sorry for that.
It's
Yeah,
like,
uh, he has worked incredible, and he's very active on Twitter and posts amazing AEC tech related. Like I'm quite inspired by his, and it's like a fanboy moment for to host this live stream. And 6 to 8 months ago, when I started entering into AEC software development, I had like my checklist or a milestone that okay, one day I wanna work with it. But now I'm hosting or collaborating with this, and okay, it feels like I achieved something on that direction. So without much ado, uh, Andrew, I'll hand it over to you.
great. Well, thank you so much for inviting me. I'm really excited to be a part of this amazing series that you've started. I've just been so impressed by the initiative you've taken in pulling together this series of, not just the like interviews and live streams, but all of the content that you're putting up on your channel. It's really exciting to me to see folks like you, get really excited about this topic and then also do the work to make it accessible to a much wider audience. I think that the importance of that cannot be overstated. And so I'm honored to be here, really excited to be a part of this. I'm going to jump right in just because I have a ton of stuff I want to get through. And so I might rush a little bit, but I want to share a bunch of stuff with you guys today. So let me just share my screen. And I'm going to start with a brief introduction of Hypar itself, just for those who maybe don't know what it is. So we describe Hypar as the next generation platform for designing, generating, and sharing building systems. So Hypar is built to make computational intelligence and generative design accessible to the whole industry, and making it easy to share, reuse, and recombine tools, processes, and workflows. And it's all built on modern cloud technologies and open standards. And so some of those words are a little bit vague. I think to make it more concrete, the founders of Hypar, Anthony and Ian, often talk about this idea. If you've ever opened up Revit, and you're starting from scratch, you're starting from this blank page, this empty sheet. And even though our firms and our practices may try to assemble libraries of scripts, pretty much in practice, we start the design of every project from a blank slate. It's always this. You're always kind of starting from scratch. Now, in spite of that, over the last 10 years, there's been this incredible explosion of computational knowledge and skill. Young graduates are going on to do all sorts of important computational work at their firms. And there's been this explosion of tools and tool sharing. And we see the examples of this in like the sharing of various computational techniques for creating parametric stadium bowls as just one example. And I think this is amazing and should be celebrated, but there's also sort of a little bit of a problem hiding here. And I call this the stadium bowl problem, which is sort of why do people keep writing these tools over and over and over again? I think there are good reasons for this and bad reasons for this. Primarily, the good reason is people are really creative and they are inventive and they come up with new and interesting techniques and strategies for thinking about problems. But the bad reason, and this is one of the things that Hypar is endeavoring to solve, is that typically it's harder to use somebody else's solution that's already out there than it is to just build your own. I ran into this all the time when I was doing Grasshopper work at firms and so on. it's just hard because, maybe they've got different hardware, whoever wrote it, or software versions, or DLL conflicts, or I don't have this plugin, or it requires a layer structure that works in such and such a way, or it's not very well documented, or it's challenging to deploy and get available to all of my colleagues. And, I think this is a real problem. We have all of this energy going towards building these tools, and yet it's not as easy as just going to grab one of those tools and putting it to work on your own project. And over the course of my career, as I've moved from working in architectural practice to working in more technology, one of the things I've learned is that programmers don't do this. They have found a solution to this problem. They do not write every application from scratch. Instead, software engineers use package managers to pull in libraries of other people's code. So a lot of the audience here probably is already familiar with this idea, but I'll explain it a little bit in case you're not. The idea is that you can just sort of write a command and immediately retrieve information and an entire package of functionality and put it to work on your project. And so for a real example, this sort of weird visualization is actually a map of the code on Hypar. Hypar's web application is built up of all of these different packages. Every one of these rectangles is sort of like a chunk of code. And the ones highlighted in red are code that the Hypar team has written. And everything else, all of the other rectangles in this image, are packages that we installed and borrow from a third party. Like, for instance, Three.js is a really amazing 3D library. We didn't have to invent rendering 3D on the web from scratch. We could just use Three.js. And this is really the principle of how modern software is built. There's your special sauce as a developer, the things that make Hypar instead of Pinterest or Instagram. But all the other stuff is out there. It's free to use. It's open source. It's this incredible, accessible body of knowledge that empowers the whole industry to build better and smarter applications. And this is one of the core ideas that Hypar is built on. What would architecture look like, especially computational architecture, if you could just utilize someone else's stadium bowl generator on your project? If you could just say, hey, give me this, I want to use it on my project. And it might look something a little bit like this. This is the Hypar web interface. I'll be showing a bunch of this later on. In fact, this video is already out of date, so things have evolved a fair bit past this. But the basic idea is I can go search for a stadium bowl generator, and I can insert it into my project, and I can just start using it, and I don't need to download anything, and I don't need to install anything, and I don't need to check for compatibility with my hardware or my software, whatever. This is all on the cloud. It's easy to just pull it in. There's an interface that I can use. I didn't have to write any code to integrate this. It's just available. And someone made a computational tool, and they put it up on Hypar, and now I can take advantage of it. So that's one of the things we'll be focusing on today, is how to actually do this, how to create a little piece of encapsulated knowledge or expertise, which we call a function, and make it available on Hypar. So to introduce a couple of the core concepts here before we dive into some real examples, I'm going to start with elements, which is sort of like the lowest level of everything on Hypar. Elements is the way that Hypar represents everything that makes up a building. So we call it the smallest useful BIM. It's a library and schema for consistently and flexibly describing the systems and objects that make up the built environment. So a level, an envelope, a floor, a beam, a column, a door, a wall, whatever. And out of the box, Elements has a bunch of these element types, but more can be added all the time. And these elements are just bundles of geometry and data. Elements itself also includes a lightweight geometry library for representing all of these concepts. So you don't have to invent the idea of a polyline from scratch either. You can use our geometry library and do things like intersections and Booleans and all those sorts of things. And Elements is totally open source and extensible. So anyone can build new Hypar compatible element types. And if there's a type of element that you want to work with that isn't currently defined, you can actually just add it yourself, even without contributing any code to our library. Elements is very much built around this idea of extensibility. And so it's very easy to add new types that you can work with. And so it's both this standard, a sort of format for representing geometry, and a library that goes alongside that for working with that geometry and doing various kinds of calculations. Next, we'll talk about the big thing that I want to talk about today, which is functions. Functions are how Hypar represents the logic of a system, like typically a building system. So we might write a function that generates the structural system for a building. And these functions can have data inputs like numbers, text, true, false values, geometry that you draw, which control the parameters of how this function executes. They can also set model dependencies. So the structural system probably needs to know something about the shape of your building and where the levels are and things like that. So these functions can kind of express what other information they might need from the model. And a function is just responsible for producing more elements. So we were talking about elements before. Functions just take in, parameters, maybe other elements, and produce more elements that get injected into the model. So my structural system makes beam and column elements, for example. And these functions can also produce data outputs. So if you need, in addition to real parts of the model, if you need specific data or metrics or analysis, that can also come out of a function. And so we let you on Hypar pull functions together into what we call a workflow. And workflows are just collections of functions that together describe a whole design study or process or a project or a specific model. And so functions in a workflow are able to automatically retrieve the elements produced by other functions. So when I said before, structure might need to know the shape of a building and it might need to know where the levels are, it can actually just reach out and grab all of the other systems in the model that it has a dependency on and have access to those when it's running. And Hypar figures out all the rest automatically. There's no, dragging a wire from the structure system to envelope. It just knows that it needs this, it connects everything together, and Hypar figures out the rest. And this flexibility is what makes it really easy to reconfigure the logic of your project. So maybe I don't like this building envelope. Maybe I want a different system for that. Or maybe I want this one. It's super easy to extract one piece of logic and plug in another because the interfaces or the boundaries between these systems are really well defined on Hypar. And we'll see some real world examples of that here in a sec. So before I dive into a couple live demos, I think, people often hear me talk about this and then say, oh, this seems like really an expert system for computational designers only. And we do provide a lot of really awesome stuff for developers, but I think our core audience is really designers who want to use computation, whether or not they want to write any code or develop any functions. So designers can use Hypar itself as a design environment. They can create this customizable design environment, and we'll see how this works, where they can just pull in other people's computational tools, assemble them into a project with interoperability out of the box with existing tools like Rhino and Revit, and they can quickly do design iteration and studies and things like optimization. And then for developers, for folks who can write a little Grasshopper or a little C# or whatever, we provide really a platform layer. This is a set of open source libraries and standards you can use. It's really rich and powerful tooling for quickly developing this logic without having to write a bunch of boilerplate. It's support for languages you already use, like Grasshopper and C# and even Excel, and we're starting to work on Python as well. And a means to share your tools without exposing your code. You maybe don't want to have to write a whole layer around permissions management. Like, who wants to do that? We did that for you. Like, we're trying to take all of the important but maybe less central work out of making a computational tool available to the world, and so that you can just focus on the thing that matters, which is, what is the logic of this building system? How does it work? How does it connect to other building systems? And last but certainly not least, Hypar makes all of this scalable because it's running on the cloud. You can execute your functions, 20 times in parallel, no big deal. Our systems handle allowing that to scale. Whereas if you've ever had to run your Grasshopper script 20 times, how painful that can be. And, there are tricks, obviously, and, I've used a lot of them myself, but it's a lot of extra work to be able to sort of quickly parallelize something that you're doing in one of these existing environments. So there's my preamble. I rushed through that a little bit. But I'd love to kind of show you this in action. First, we'll just look at how a workflow might be assembled. And then I'm going to show you how we actually would author a function in one of these workflows. So we have some really cool templates, which let you build stuff up from scratch, or build stuff up where you don't actually have to start from scratch, where we've already picked out some functions for you. But I'm going to show you how you might assemble a workflow from scratch. Also, I should mention, Hypar is free to use. You can sign up for free today. You can start using it. There are some features which are paid features, but for the most part, everything I'm going to show you today, you can do without paying a dime. We really want to make it easy for developers to get on Hypar and just start building useful stuff. So if we have a project, we probably want to locate it in space. We probably need to say where it is. I'm going to put it in downtown Seattle because I was just there. Let's say, how about we'll do something like over here, maybe. And, we'll just automatically fetch the GIS data, the map, maybe the 3D buildings we're going to want, 3D topography for you to work with. And other functions can rely on this information. So let's just pick a site. And I'm going to go like right here. I'm also going to say, let's clear away the existing buildings here so that I'm not intersecting with them. And I'm just going to start building up a kind of a little low-rise tower project. So we're going to want a building envelope. And there are many ways to produce a building envelope. Some of these Hypar has written, some of them our contributors have written. You could write one. You can do it with Grasshopper. You can do it with C#. I'm just going to use, let's do envelope by center line. And I'm just going to draw like a simple center line, and we'll make kind of like a, I don't know, like a hook-shaped building here. And we'll get our building mass. And maybe I want to visualize this with a facade. So I'll drop in a facade function. Maybe I'll have a curtain wall facade. And one of the magical things about Hypar, because of what I described earlier, is that these functions know when they're missing information, when there's something else that they might need to run. So in this case, the curtain wall needs a facade grid. And if I click on this, it'll show me all of the ways I could potentially produce a facade grid. So let's make one by levels. And that's going to need some levels. So I'll drop in some levels. And pretty soon I should see a facade grid show up, some levels here. Then we'll get our grid, and then we'll get a facade built up around this. And it's going to look a little funny at first because there aren't any floors in here. So this floating facade is maybe not super realistic, but let's just drop in some floors. By levels maybe, and then we'll drop in a core as well. And all of these entities are BIM objects. So if I click on this floor, I can inspect it. I can see all of the data associated with it. I can see how it was drawn, things like that. And all of this stuff can be imported or exported to Revit or Rhino. And one of the really cool things about this environment, which I think is sort of some of our most important magic, is that even though the core, for instance, is defined by these parameters, I can also get in and make manual adjustments. So this is something that's really hard to do in platforms like Grasshopper or Dynamo, where you want to allow a level of kind of like manual control, but still keep everything parametric. In Grasshopper, like either you bake it and then you lose all of the parametric associativity, or you leave it parametric, but then you don't have enough control. And so on Hypar, you can do a little bit of both. I can kind of decide parametrically what I want the size to be, but then I can edit. I mean, I know that's a funky core shape, but I can edit it dynamically. So that's a really brief tour of Hypar's interface itself. And so the question then becomes, how do we interact with this? How do we start to build our own systems? And so currently there are kind of two primary and one slightly secondary language by which you can produce these building systems. If you scroll down on the Hypar UI, you can go to the new function button and produce new functions from C#, Grasshopper, and Excel. And the only reason I said Excel is a little secondary is because it can't produce geometry currently without a little bit of help, but you can do this to do like, a cost analysis or whatever you might need to attach to your project. And this can, just like other functions, consume information from the other models in your workflow. So let's start with Grasshopper. Let's make a new Grasshopper function. And if you do this today, you might see a slightly different version of this. I'm operating with the beta version of our newest Grasshopper, which should be going live soon. But if you would like access to this beta, just contact me, and I'll make sure to get you on the list. So let's say, my first Grasshopper function, and I can define what I want its inputs to be, what its parameters are. Let's make one based on a polyline. We haven't really seen that yet. And I'll say this is my center line. And I can specify how this function might connect to other functions, what it might depend on, or what outputs it produces. I'm not going to do this right now. And then I can add data outputs. So maybe we want to know like the length of that polyline. And we can tell it what units it's associated with. And then we're basically ready to go. And I can say publish this function, and it's going to give me this ID. Now, this process looks basically the same for C# or Grasshopper. In Grasshopper, we're going to work with it like this. So I'm going to go, I already have Grasshopper open. And let me pull my Rhino window up here as well. And what I'm going to do is I've logged into Hypar. There's a Hypar plugin for Grasshopper with a Hypar menu. I'm already logged in, so I can open up the Hypar menu. And in this case, I'm going to work on an existing function. I can also do create a new function directly from here, which will take me through those same steps we just went through. But this is where I'm going to need that ID. So I'm going to copy that ID and paste it here. And it's going to automatically create some components for me, which have the inputs I defined, the outputs I defined, and I can now use this as kind of like the bookends of a definition that I want to run. And so right now there's no information coming out here because I haven't drawn any center line anywhere. So I'm just going to create like a test piece of geometry here. And I'm going to load this in and make it my sort of sample geometry. Now that feeds in here. And let's just do something really simple like a mesh pipe. Or maybe I don't have mesh pipe on here. So I'll just do a pipe and then we'll mesh it. And we'll set this to a radius of like, yeah, something like that. And then I'll make it into a mesh. And we wanted to output the length. So I'm going to take the length of this line and we'll plug in the mesh. And now I can say publish this function to Hypar. First, I have to save it. So we'll say this is my pipe demo. Oh, and it's warning me that I have some internalized geometry. And so I'm not allowed to do that. So in this case, or I haven't internalized it. It's like a reference, which of course won't be accessible when we put this up on the cloud. So I can either internalize the data, which is what I think I'll do here, but eventually I'll just get rid of this. So let's try that again. We'll publish our pipe demo. And then I actually want to see this on Hypar. So we'll go test function on Hypar. We'll create a new test workflow, and I'll call it pipe example, and create and open it in the browser. And so this is going to fire up my browser. And if I'm not logged in yet, I might need to log in, but I already am. It's created a new Hypar workflow for me, and it's added a copy of that function to the workflow. And so now if I draw a new polyline here, something like this, it will re-execute using that as the input. And this is all running on the cloud. Now that's pretty fat. Maybe I want the radius to be a little smaller. So maybe I'll set this down to something like 5. The other thing you'll notice is that because I'm testing, I'm using this as my test workflow. It's actually pulled in the input that I drew on the web. So I no longer need my sample polyline here. It's actually feeding this directly from the workflow that I'm testing with, which makes it really easy to like debug and set things up the way you want them. So here's this pipe. That's looking a little better. Now I can publish my function again. And if I go over here and let's just edit our polyline one more time, just a little bit. I should see something with a smaller radius. So maybe I want to add a few new inputs. Like maybe I want this radius to be a control on my function. So I can do this a couple ways. I can either edit the function configuration, which brings me back to that kind of wizard dialog, or I can just select this slider and say, convert number slider to function input. And that's just from the Hypar menu up here. Now it's added it in as one of these parameters, and I'll have to, I think it'll actually publish that for me automatically. I'll have to reload here to see that new input, but now there should be a slider here. And now I can control the radius of this by editing it right here. There's a chance I'll have to re-upload. Yeah, I think I probably have to republish here just to make sure that that radius is actually what's driving this pipe. But now, if we go back here, it should vary that radius. There we go. So that's the kind of basics of creating a function with Grasshopper. It can get like super involved. There's a lot of advanced things we can do, like take into account dependencies on other functions. I'm going to demonstrate most of that through the lens of C#, but a lot of the concepts are really the same, where we'll be setting up things like model dependencies. So let's create another function. This time, we're going to use the C# developer tools to write one in C#, and we'll do something else. So I'm going to go back to the main Hypar page. I'm going to scroll all the way down to my functions, and I'm going to go create a new function, but this time I'm going to choose new C# function. And I'm going to say my first C# function demo. And this time, what should we do? Let's just do like a couple sliders here. I'll say this is like the width, and this is the length. And we'll go like that. I'm going to leave all of this blank for now. Maybe I want to specify like a volume. And I'll set that to be of type volume. And click next. And I'll click publish function. And this time, instead of giving me an ID, it actually gives me a command. And so Hypar has a command line interface, which you can install. Incidentally, all of the documentation for this, I'm going through really fast, but if you want to kind of see how to do this yourself, all of this is documented on docs.hypar.io. So if you go to the C# section, you can actually run through this a little bit more slowly. But I already have the Hypar command line tool installed. I'm going to navigate to my like repositories directory. I'm going to copy this command and I'm going to paste it. And what this is going to do is spin up a whole C# project for me, which is the kind of bones of the skeleton of a new Hypar function. So that all I have to do is provide the logic, provide the rules for how I interpret these inputs and how I produce new outputs. So this one is a little bit slower than doing it with Grasshopper, but C# is ultimately, I think, a little more powerful. And also the C# functions will typically be a little bit more performant than a function that you write with Grasshopper. So I would say if you're not super comfortable with C#, Grasshopper is a great place to start. If you're kind of debating which system to use, I actually think starting in C# is a good way to go. You'll get a good grasp of the kind of underlying concepts, and all of that knowledge will translate to working with Grasshopper as well. The other thing is that if you're working in Grasshopper, you have access to all of the like Rhino geometry functionality, which in some cases does things that Elements, our library, does not. So, you know, working with NURBs or other sort of curve geometry especially. So while I was chattering away, this has created a folder called My First C Function Demo. I'm going to move into that. And I'm going to open it up with Visual Studio Code, which is my preferred IDE for code editing. You can do this in Visual Studio too, if you're more comfortable with that. And it's spun up all this stuff. It's created a file here called hypar.json, which sort of collects all of the choices I made, like the inputs that I decided and whether there are any relationships to other functions. And then it's also created a bunch of C# code for me. So it's created classes that correspond to those inputs and the outputs that I need to produce, like volume here. It's produced a function, which is just a sort of empty method here called execute, which I have to fill in the logic for in order to create my own Hypar function. And if I had any dependencies on other types and things like that, those would have been generated automatically as well. So let's go ahead and just create, the sort of hello world of 3D, which is like a cube. And so because it generated all of these classes for me, this input argument actually has the values that I set, like width and length that I defined when I was designing this function. And so if I want to create like a rectangular profile and extrude it up as a box, let's do that. I'll say var rectangle is equal to, and I'm going to call polygon.rectangle, and I'm going to use input.width and input.length as my parameters there. And then I'm going to say var mass equals new mass. And I'm going to use that rectangle. I'm going to set it to a height of 1 for now. Maybe we'll adjust this later. And I think that's all I need to do. There are a bunch of optional arguments there. And then the last thing is, in order for something to show up in the Hypar environment, similar to how we passed these values back out to this model output in Grasshopper, in C#, I do the equivalent thing by saying output.model.add element, and then I can put this mass in it. And so I'm now done. I have created a Hypar function. Now I have to publish it up to the web so that I can start to use it. Because if I go to Hypar now, and maybe I'll go back to that demo workflow I was using, and we'll say my first C# function demo, it's going to yell at me that there's no logic here. Actually, it didn't yell at me, but it's not doing anything. There's like nothing being produced. And so if I want it to actually execute this code, I have to publish this function to Hypar. So I opened up a little command line here as well, and I'm just going to use the Hypar command and say Hypar publish. And it's going to go ahead and build this. It's going to put it up on Hypar for me, and it's going to make it available to me. One thing to note, which is a question we often get, is that these functions are actually private to you to start. Nothing will be visible to anybody else on Hypar until you explicitly decide to share it and make it available. And obviously, we encourage that when you've got something working, but we didn't want the UI to be crowded up with a bunch of stuff that's only sort of like half working. So this gives you a chance to kind of develop locally, test it out, make sure it works in your workflows, and then share it with the world, and then it'll be available for anybody to use. And of course, you don't have to do that. It's kind of the dream of Hypar is to have this incredible wealth of shared knowledge. So I've gone ahead and published this. Now, if I adjust this slider, we should see a mass whose size is dictated by these values. I'm going to hide the visibility of my Grasshopper function real quick. And so as I change this, it will change its size. And in fact, and this is one of the really cool things that Hypar gives you, although I think this is now a paid feature, we have a sort of first tier subscription of, I think, about $16 a month. And this is one of those sort of advanced features. But if you check this box, we will automatically generate 20 variants for you that sample all of the different values along here. So actually, I think in this case, I got a little bit fewer. It's just calculating the thumbnails, but it's actually completely computed the geometry of all of these options based on different values for length. As I hover over them, you can see the little tick moving to show me where on the slider this value represents. I can also turn on the volume and the width and the length to see what values were used to produce each one of these. Also, you'll notice that volume is 0 because I haven't actually calculated it yet. So let's go back and fix a few things. I also probably want to add a new value here, like a new input, so that I can control the height of this box as well. So let's do that first. I'm going to go to About My Function, go to Inputs, edit my function details, and add another range, and I'll call this one height. and I'll say save changes. And also while I'm here, I probably want to set these all to be of type length so that they'll render the proper units. They'll show meters or feet instead of just a number. And I'll save those changes and close. And whenever I make changes on the web, in the local project, I'm going to have to do Hypar pull, which will bring in those changes that I made to the function. And I also have to do Hypar init, which just regenerates the C# code, the automatically generated C# code based on the choices that I made. So if I want there to be an input.height value, I have to run Hypar init so that it brings that in. So now I should be able to say input.height instead of 1 for my mass. And I also probably want to set the volume. And in this case, my outputs class has an empty constructor, but it also has a version of the constructor that takes volume as an argument. And so I'm going to feed that in as input.width times input.height times input.length. And so we'll publish that again. And as soon as that has finished, I'll be able to go back to the workflow and re-execute it. And this time I'll be able to control the height as well as these other parameters. And this may seem, this is a little slow, but if you think about everything that's going on here, like we're like establishing an entire cloud service for a function that you wrote, like it's hard to imagine how it could be, much simpler. So this is now re-executing, and now the height is controlled here. Also, maybe I don't want there to be a 0 length. Maybe that's a silly thing. So maybe I just want to confine the range that we test to between 40 and 100. And now I'll get a different set of options visible here. And now we're also calculating the volume, and it's doing it in meters cubed because I gave it the right units. If I switch to feet, oh, that's a bug. It should have updated there too. Interesting. I'll have to fix that. But you can see that the inputs here are showing up in feet instead of meters, and that should also be true here. If I see, oh, actually, it won't be a property of the element. But if we look at like the outputs of this function, it should be calculated in the correct units. So I do have more things to show, but I just went through at 1,000,000 miles a minute. And I would love to maybe pause for a couple questions, chat about what we just saw, and then I can kind of direct what we cover next based on what folks are interested in.
Yeah, like it was like a power dose of great developments at Hyper. And few questions I had is, so in your first example for Grasshopper demo, what if there are some plugins installed in Grasshopper? How does that goes into cloud and compatibility?
Great question. So out of the box, we support a handful of plugins. Most of the ones that I've written are supported except Human UI. And then I think we support Wombat. We support, I can't remember the list off the top of my head, but I think if I try and use a plugin that's not allowed, when I go to hit publish, it's going to warn me that there are some components or libraries that are not permitted. So you'll know before you publish, but I would just recommend, publishing often so you don't build out a whole thing that relies on that. And, if that's a huge limiter, if you like absolutely need to use a certain plugin, like I think we just added support for a couple more, like Lunchbox, and I think we support Pufferfish now. So those should work. But if there's one that you absolutely need that we don't support, then like get in touch. We can talk about it. There are security reasons why we don't just let you run any old plugin. And it's also something where, enterprise customers who have an engagement with us can probably discuss having special plugins added for just their use. So, don't let this be a blocker, but, I think you can build quite a lot with the set of plugins that are already available for use.
And similarly goes for C Sharp. Like if we download libraries in that.
Yeah, so in C Sharp, it's actually not restricted because each one of these is a very neatly encapsulated microservice. And so we can actually allow you to add Nuget packages. So for those who are not familiar, Nuget is actually a lot like what I was describing earlier with NPM, where it's a sort of C Sharp or .NET package server. And there are a ton of incredible packages that are available. So as long as your package supports .NET standard, then it will work with Hypar. So you can just add a package in VS Code. You just say add package, and then you can search for something. And in fact, there are Hypar packages that you might want to use, like Hypar dot, I think it's called components. Yeah, Hypar elements.components. And there are lots of other packages that you can add, and that will just get built up and made available online.
Got it. And I was comparing this like workflow with the workflow in GitHub. And so in GitHub, you can do like revisions or library updates. So what if someone has a function update once they publish? Like, does that come as new or it's 2.0?
It's a really good question, and it's something we've been discussing a lot internally lately. Currently, the behavior is that if you publish your function, it updates immediately for everyone. And there's something good about that, which is that you don't have to be sitting around, manually upgrading all of your code. But it does also mean that there's a risk that somebody, you're relying on a function that somebody wrote and the logic of it changed, and all of a sudden your project is different. So we are actively working on strategies for supporting this. We don't want to just stick you with old versions forever. One of the things we've talked about is something like an automatic diffing strategy, where you can publish a new version of the function to your heart's content. And as long as it continues to produce the same results for the same inputs, then, inputs that are already being used in other contexts, then you're free to do it. But if you're going to introduce a breaking change, then maybe we restrict that, or we find a mechanism to perform some sort of a migration or an upgrade. It's a complex topic. It's a really hard thing. But we're working really hard to solve this problem. And so, I think the only advice I'd give is if you start writing functions and people start using them, then just be a little careful before you publish. And I should note too that when you author a function, like let's look at a function that I've written, like space planning zones, for instance. I can see in my stats how many people are actually using my function. So I can get a sense that like people are using it. This is also great feedback if you, which of your functions are most popular? Which ones should you spend time working on? Which ones should you improve? And so, you can kind of see what people are doing, what level of activity the stuff that you're building is getting once you make it public.
Got it. And I want to know, like, is once you publish a function, let's say I build a API a reader function, once it's on the cloud, is it requesting like callback real time, or how frequently it's making a request to read?
You're talking about a function that maybe calls an external API, or yeah. So it will only execute when an input changes. And so it's not going to sit there like looping and polling your API. It will just issue a call when one of our inputs changes. And similarly, we don't pull for function changes, although I think eventually when a function changes, the results will be updated automatically. But yeah, it only happens on demand.
Okay, so if I were to engineer like API which reads satellite location like every 5 seconds, do I need to change input manually, or can I automate it?
Yeah, and we've had a debate on the team internally about whether or not a function should have like a refresh button or something. So you can just say like, my inputs haven't changed, but I want the latest value. In general, I think we sort of operate on the assumption that Hypar functions are meant to be fairly deterministic. So like you shouldn't get different inputs for the same, or different outputs for the same inputs. I think one example of this, I think we had, maybe it's on dev, but like a function that would automatically like retrieve the latest weather at the location you're at. There are all kinds of challenges with this. It actually touches on what we talked about earlier, where like, I showed up to use my function and now everything is different. But if this becomes a common user request, we can find ways to sort of safely support things like functions that want to be able to update live, or that do change their values based on live data. Like maybe you care about the cost index for steel when you're doing, costing, and it updates in real time as the markets shift, like stuff like that. I think we could ultimately support.
And like you guys have already done a lot of great software engineering like problems in. So when I was going through the like your demo for Grasshopper function integration, and you showed that you can, even once you publish, you can have additional input. Like, how does it work in backend? I am just curious. Like, it's so many stuff is going on.
When a new input is added?
Yeah, like.
So basically, everything is tied into Hypar's core API. We have records for a database full of all of the functions and all of their logic and all of this stuff. And so when I have like, let's change this so that it supports a color. So let's do like a swatch here, and I'll make it a color like red. And we'll do the same thing. We'll say Hypar convert color swatch to function input. So what it's doing is it's looking at this input. The Grasshopper plugin itself is making a guess about like what sort of an input it should produce. So it only knows a finite set of these objects. So in this case, it knows to produce a color input. If I'll use this as my sort of sample value, and I'll also say, I'll make this into a mesh element so that I can give it a material. And I'll use this color as our material, and I'll put that in here and I'll publish. And so when I publish, I'm just updating the record. And that record, in fact, what you see when you look at hypar.json is very similar to the record of the function. So all of these properties, so I could do the same thing here. I could add a color input, which is of type color, which I can look up by going to the docs. There are all of these different like input types which can be expressed. And so a color is just this. It has a sort of a schema that it refers to. And when I drop this in here, in fact, we'll do that as well. So basically all that's happening under the hood is it's adding this color record to the function and publishing that function up to our API. And then all of our services, like the web UI, just are always fetching the latest version of that function record. And so now it has a swatch, which I can control. And if I change it to green to cause it to re-execute, we'll have a green pipe. Did that answer your question?
Yeah, I'm still understanding. Like, so all the functions which are in Rhino have been like converted into JSON format, which is readable in the cloud.
And so, so the Grasshopper piece isn't quite like that. I am doing a sort of conversion to JSON just for specific input objects. So in order to do this magic trick where you select a slider or a swatch, I do a translation into JSON, but we're not translating the bulk of your function into JSON and executing it some other way. We are in fact running an instance of Grasshopper. So we are, in addition to publishing the input, we are also saving a copy of your file and executing it in a similar mechanism to like Rhino compute, where we can actually run this script and retrieve the results. So that one of the things that means is that, we didn't have to rewrite Rhino common from scratch. We can rely on the Rhino, and that you're going to get the same result executing on the cloud as you do locally. So most of this is in fact just us taking your Grasshopper script and running it on a cloud service, which is set up to be, robust and parallelized and other things. But yeah, you are actually running Grasshopper every time I, I go like this, it is actually calling into a service that's running Grasshopper itself and using its own logic. So we haven't like reverse engineered Grasshopper or anything.
Oh my God. Yeah, that makes a lot of sense that you're running Grasshopper. Because I got confused. You said like you're importing geometry in 3JS, like how the
Yeah.
Rhino Common and Rhino Compute is being imported. Are you installing library in 3JS or I don't
Yeah.
um,
It looks like we have a
mm.
raised hand.
Yeah, go ahead, Aprama.
Yeah, hi Mayur. Hey Andrew, thank you so much for that very insightful demo. So I just had a question, like, so on Grasshopper, like if I have like a custom script running on like say GH Python or like C# script, like something that I coded up on my own, does that also sort of like reflect and to sort of like follow up on that, like are we able to sort of like access the source code of all these functions as well? Like, are we able to sort of like study it so that we can maybe like reverse engineer our own logic and sort of like attribute that as well?
Great questions. So for the same reason we can't support arbitrary plugins, if I try and publish a function that has a C# or a Python script in it, we can't support this. The reason for this is that those scripts have incredible access to the file system, and it would be a security hazard if your script could like go look at results produced by someone else's script. So we're pretty cautious about this. If you want to write custom code and utilize it, then you'll have to do that by writing a C# function and not utilizing Grasshopper. And we realize that that's a little bit of a trade-off, but I don't think there's any good. I mean, this is true for any service I know of that does sort of Grasshopper computation on the cloud. I think it's always a security risk if you're going to allow people to execute arbitrary code on your servers. And we get to do that with our C# functions because each one is a little microservice. It's super encapsulated and isolated and doesn't have access to anything it shouldn't. For your second question about being able to look at the source, the answer is for many functions, yes. And so when you are looking through the function library, like let's look for plan by program, which my colleague Anthony wrote. There will often be, actually, it doesn't look like there is an example of this here. Yeah, here we go. There's like a repository URL, which you can attach to your function. So if you have chosen to make your function public, then it will, you can link to it from the function directly. And that's actually open source and public are two different concepts on Hypar. You can make the function public so people can use it without revealing the source. And you can as well choose to reveal the source if you would like, which is just, it's kind of up to you to make that repository public. But for a lot of the built-in functions that I showed, like envelope and other things like that, a lot of this stuff is on a repository we call building blocks. So github.com/hypar-io/building blocks is where a lot of the kind of core functions live. So stuff like drawing cores, drawing envelopes, drawing facades, things like that. These are all open source. And you can get in here and see exactly how they work. You can see what APIs we're using in order to produce them and things like that. So, and of course, we encourage all of our contributors to do this as well, but we also don't strictly require it. There are good reasons why somebody maybe wouldn't want to open source a function, but it's strongly encouraged.
Awesome. And I'm still so when you start a new workflow, you start in a 3JS environment, you are adding geometry, you have that workflow which has dependency of site, envelope. And when we create a new Grasshopper function, it's running on a GH instance on cloud. So how are you like integrating that in 3JS environment?
So, I mean, 3JS is just our visualization layer. And basically, every function winds up outputting two pieces of information. One is the elements JSON, which is just our model representation format. And this is that's the kind of open source thing I pointed at earlier. There is a sort of standard JSON format, which represents all the elements. You can even look at this by going to download a JSON file, you can see what we produce. And the other thing that every function produces is a GLTF, which is sort of a standard 3D web format that Three.js is compatible with. So I'm just going to open up that JSON file real quick, just so you can kind of see what we're looking at. If it will open. Oh, here we go. Yes, I trust myself. So this is that Hypar JSON format. This is an encoding of everything in the model as kind of core element information. And then you can also get at the GLTF the same way. There's a GLTF file, which you can download and use in other contexts. And so basically every function is just responsible for spitting out a JSON and a GLTF, and we use Three.js to load in that GLTF, and then we use elements to endow it with all of the like data. And so that other functions just receive the elements. They don't actually receive the GLTF. They don't need it. That's just for visualization purposes. And so if I created a Grasshopper function that depended on another piece of information, like say site. Actually, let's do this in C#. I think it's maybe going to be easier. Let's see. So if I wanted to create, actually, let's try it in Grasshopper. We'll see if it works. So when I go to edit these function details and go to my connections, I should be able to add a model dependency on site. And I'll hit save changes. And now this function is designed to receive information that the site function produces as its output. And so now if I go back to Grasshopper and I say pull configuration changes, it should recognize that there's a site here to work with. And we're going to have to, let's just execute this one more time. And hopefully that will load in this piece of site information. I might have to manually refresh to get this to show. But it's actually going to bring in that element, which was sort of translated from that JSON data, so that I can start to do things with it. So this will take a second, but now you can see that actually, did it come through? Yeah, so there are, if I hide my other stuff here, there's a site coming in through here, so I can filter this stuff by type and say, give me the site out of this, and then I'll deconstruct that element. So there are special Hypar components that can consume those elements and turn them back into Grasshopper geometry that I can work with. So now this is the site that I drew. And again, if I make a change up here, like, I'll introduce a little kink here, then that should also feed back through to my local development environment. It might take a second. And sometimes we lose connection and I have to manually refresh, but it should update the shape of this site for me to test against. And then I can do other things like, let's just extrude this site up just for fun. And so now I've got an updated perimeter here. Maybe I want to, let's just extrude that representation up in the z-axis by like, I don't know, 20 or something. So now we've got some, oh, you know what, did it do that? Or it's just a units thing maybe? Here, well, let's just use the perimeter and that should work. And then I'll feed that in here as well and publish that again. I've still got my C# in here. And now it's actually depending on this geometry that came from another function. And so this is where stuff gets really powerful. Like, you don't have to write the whole script yourself. You can rely on the stuff that came in from other contexts. So now this is being produced by Grasshopper, but this is being produced by a C# function. And those things are all talking to each other just by transmitting this common data representation.
Yeah, that's super powerful. I feel it. And I want to know like how you solve the problem of integrating multiple functions in the workflow. Like Rhino Common or Rhino Compute allows like a single like local server or instance, but now you are open for everyone to share it. Like,
yeah, I mean, the basic logic of this is just that functions are microservices for the most part. There's a little bit of an asterisk there when we're talking about Grasshopper because the architecture is a little different. But in general, every function is a microservice, and those functions pass around JSON, the element representation, and that's pretty much it. And then they produce more JSON as well as the GLTF. So we can totally orchestrate these complex relationships by basically just, calling into one function, getting its results back, passing that to the next function, and so on and so forth. And so that makes it very asynchronous and very stable.
So you have a single in cloud server running. What are the JSON input and output for all these functions?
So yeah, the orchestration currently, actually, this is a little bit of a detail, but the orchestration currently happens on the client side. It's actually constructing a graph of the relationship between all of your functions, and it's handling when it requests to these services, but that'll change. We're in the process of moving that to also be a backend thing, because it'll open a lot of doors like real-time collaboration and all kinds of other stuff that will be really cool. But yeah, it doesn't even really matter where it lives so much, but suffice it to say, there is a service whose job it is to look at all of the functions in your workflow, figure out how they relate to each other, and figure out when to call into one or another with what data.
I see. Yeah. And what was the most challenging part of your whole development work? Like, which was like, oh man, this is.
I think probably the most challenging thing is figuring out how to make something that is powerful and extensible while still being user-friendly. And I think we've got more work to do on this front. I think, we think this is a pretty simple UI, but some people are still intimidated by this. And I think, this was always the thing I ran into as a computational designer for architecture firms, is that people are terrified of the complexity of things like Grasshopper. And it's been a real barrier to adopting computational techniques in the industry. And so I think there's a technical challenge and a design challenge involved in empowering people to build really complex and powerful stuff that's extensible in 900 different directions, but then present it in a way that somebody who doesn't know anything about the underlying architecture or the way that these systems relate to each other can just use and feel like they're just modeling a building. To me, that's the biggest challenge.
Nice. Daniel had a question.
Yeah.
Oh, hey, Andrew. Thanks for the wonderful presentation. Hey, Mayor. I just had a quick question. I'm trying to, understand how, Hypar fits into, let's say, a workflow of an architect. Do you go from, building sort of your conceptual stage in Rhino, or are you kind of you can start from Hypar and then just shift it around into, say, Rhino, or if you need more documentation to Revit? Or is it kind of, is it going to be essentially a standalone thing, or is it always going to be sort of a connector between those softwares?
Great question. I think that in the long run, we want people to be able to design a building completely on Hypar. You should be able to do a whole project beginning to end on Hypar. We also know that's not possible yet. Certain functions are missing, certain things that would really be necessary in order to do that are just not present, like 2D drawing generation and other stuff. So we have really focused on interoperability. So it's kind of up to you to figure out how this fits into your process. But some common ones are, starting in Revit, bringing it into Hypar to do some analysis or some automated process, and then bringing it back into Revit for documentation. Or the same, but with Rhino. Maybe I want to model a building mass. So actually, let's do a demo of that really quick, just because this is all pretty new. I'm going to close this Grasshopper thing for a minute. I'm going to check my units and just make sure I am in meter. Actually, meters are feet. Let's do feet. And I'm going to just model some geometry here. Let's do a polyline. And we'll go something ugly like that. And I'll make it into a solid. And then let's do one more tier, maybe. And so, you could absolutely start your process in Rhino. A lot of people we know already are doing this. So let's say Rhino export. So you can actually read in a 3DM in the Hypar context. So let me just hide some of these things. And I will find that file and I will drag and drop it here onto the window. And then I can start using all of the cool automation that's on Hypar on top of this Rhino model that I've created. So let's see if that loaded in. There it is. So if I want to put like a facade on this, like my demo earlier, let's say curtain wall, we need to do a few things. So just like before, I'm going to need to give this a facade grid. It's going to need to generate some levels, and it's going to need an envelope. But this time, instead of drawing an envelope using another function, I'm going to say, get your envelope from the Rhino model. And I have to do two things here. I have to say, these two things are envelopes, because in Rhino, everything's just geometry. And in Hypar, everything is a BIM element. So it has to have like a type associated with it. So first we have to tell it what type we want it to be. And then we want to tell it what we want this function to produce. So in this case, envelope is also the name of that dependency, which this thing can consume. But as soon as I've done that, it'll start generating levels, and, I can drop in some floors. I've got, I can put in my curtain wall. I can put in a core. I can go really far with this. I can, one of the use cases of this that we've been doing a fair bit of work with lately is like interior office layouts. This building is pretty funny shaped, so chances are this will do a slightly funny thing, but we'll do space planning zones on this. And this is going to generate like spaces in the building, assuming a kind of an office program. And let's make that open office, and then I'll drop in open office and maybe some meeting rooms too. And these functions are now all going to consume those spaces that were generated and try to like lay out desks. So you can see we've actually like super quickly from that Rhino model, I mean, it was only a matter of minutes, gotten like a full furniture layout here in our model. And so if I want to bring this back into Rhino for like a real world use, or into Revit if I want, I can spit this back out into Revit and have all of my like, families and stuff. But if I just hide some stuff I don't need, like actually, yeah, we'll just hide this guy. I can download this as JSON. And with the Hypar plugin for Rhino, I can now just drop this right back into my model. So if I say, here I am, I'm going to open that JSON file. I'm going to drag and drop it into this window and say import. Then it's going to create that whole thing as sort of native Rhino geometry. So you can absolutely just use Hypar for a kind of piece of your process, some little piece of automation that you need, and then just go back into the platform you were working in before. So let's see, this will probably be hidden by my extrusions from before, but I can, maybe I'll hide the layer that these guys are on. And let's see what else. I'll have to hide a little bit more. Yeah, I'm on the wrong layer, I know. And we should see all of that stuff brought in, as well as like, native Rhino extrusions and block instances and stuff like that. So it's not like, crazy heavy either on your model. So, if I wanted to change the material of this desk, I could, and it would update everywhere. So that's a long-winded answer to a very good question, which is just that like it's kind of up to you where the in point and out point is for Hypar in your workflow. But we're trying to be really flexible about that and just allow you to do whatever is going to work for you. You could start in Revit, bring it into Hypar, and then finish it in Rhino if you wanted. And we support that sort of an approach.
Is it right?
Yeah, that looks great.
Yeah, is it right to say that whatever stage you use Hypar, you're using a smart workflow and automating the tedious task?
Yeah, I mean, I think that is a core principle here, is that like we want to allow people to take advantage of the power of automation in their real workflows. And doing this today in existing software packages is still painful. And it's okay if you're an expert and you really know how to fire up Grasshopper and you know how to, run the Dynamo player and do this thing and, get that thing installed exactly the right way. But not everybody is going to be able to do that. And so if you really want to make tools that support this kind of smart automation in a way that anyone can use, that anyone can just pick up and incorporate into their workflow, then, that's what Hypar is aiming to do. And we will keep working on making that feel fluid and natural from within the platforms that people use today, because otherwise people won't use us. If it's too many clicks or a little too painful to get into Hypar, then people won't. But I think we can certainly demonstrate the value, like, oh my God, that's so much faster than what I used to do. And we can also, bring Hypar closer to the native platform. Like maybe you don't have to go all the way to a browser. Maybe there's a little embedded window in the UI that lets you do this stuff, like those kinds of things as well.
Awesome. Now I would like to ask.
I had a.
Sorry, go ahead.
Sorry, I just had one more question. And then I was curious. So, for example, when you're loading up all these functions and you have a whole variety of users, like loading a whole bunch of functions, like how do you, I guess, because like one of the issues that I usually have is like, for example, either like in Dynamo or in Grasshopper, you get a whole bunch of plugins, and sometimes like it's kind of hard to keep track, like which ones are good, which ones like you don't really need anymore, and that whole update. So how do you curate those functions from like a whole bunch of users once this thing gets like going and becomes more, I guess, like a wider space?
It's a great question. And it's also something we've been talking about a lot internally. We have a little beta that like sorts these functions according to which ones are most popular, which ones get used the most. I think we have a lot of ideas about how to support this and how to make this more streamlined, and not a lot of those available yet. We're not quite at the point where there's an overwhelming number of functions, but we're quickly getting there. I mean, if you wanted to create some levels, how would you know which levels to create? Like that's a real problem. And so we are, working to figure out how to make this stuff available. And I think ultimately the information that you need is like, okay, are a lot of people using this successfully? Have people rated it highly? Which ones did the Hypar developers produce versus just some random person? Like maybe we have a trusted function author certification, or maybe it's like, oh, this was produced by someone on my team, so I trust it. There are many, many, many signals we can use to basically like rank or suggest the right solution for you in a given moment. But it's a real problem we'll have to solve. There's very quickly we'll be bordering on this place where it's like really hard to know which thing to start with.
Mm-hmm. Yeah, thank you for your answer, Andrew. Thank you.
Now I'd like to ask few light questions on, like, I'm personally curious to know, like, how, like, what's your story of meeting like founders of Hypar, and how was the pitch?
Yeah, okay. So I've known Ian for a long time. I was still at NBBJ, which was my first job out of college, when Ian was working on Dynamo. Ian, for those who don't know on the call, was the sort of original author of Dynamo. And so he came around and gave a presentation. And I thought it was really cool and awesome. And, we had kind of stayed in touch, and, that like on Twitter mostly, and just, giving each other shit every so often. And, we would run into each other at things like Autodesk University. I also, I met Anthony, the other founder, in a similar way, various conferences and things like that. And so we had always been kind of, aware of each other. And I had been working at WeWork a couple years ago, and things had started to get pretty weird. And I still look back very fondly on my time at WeWork. It was a really exciting place to be working on these problems of like design automation. But there were also a lot of things that were really frustrating about being there, especially towards the end. And it had started to make the news a little bit. It was like, everybody knew that WeWork was like going down. And I got a call from Ian, it might have even been like a weekend. And he was just like, hey, how's it going at WeWork? And at the time, I think it was just Ian Anthony and Matt, who's our CTO. And they were like, would you be open to talking about this? And I said, yeah, I mean, things are getting a little weird here. I'm interested in this possibility. And and we talked, and I remember we met in person in New York. I think Ian and Anthony were out for a conference, and we had coffee, and Ian pulled out Hypar on his iPad and gave me a little demo, because I had been sort of aware of it before that. We had talked about it a little bit in its very early stages. And then he showed me what they called them the cauldron, which was the very first time we had workflows. It was like functions that can talk to each other. And then he showed me, like, on his iPad, like drawing a polygon right then and there and having a whole parametric building system spring up. And I was like, that is so cool. Like, I want to be a part of this. This is just the most, like, amazing thing. It just feels like the future. And it's really exciting to me because, and sometimes we struggle a little about this because we talk about Hypar like it's the future. And what I want to communicate to people is that it's not the future. It's now. Like, it's happening. Like, it's time to get on board and start using this stuff. But it has this, like, I think this is what the future looks like. This is the way that design practice needs to evolve in order to fully realize the potential of computation. Because right now, there's so much cool stuff that happens, and it just, we show it off at a conference, and then it dies on someone's, in a Grasshopper script on some server somewhere that, and somebody quits, and then nobody can ever open it again. And, like, it's just not sustainable. And there are so many opportunities to be more streamlined and intelligent about how we approach the design process. And I think also we're seeing a lot of this. I've totally moved beyond the scope of your original question, but just to finish the thought, we're getting really excited about our kind of contacts with folks who are doing, like, totally different business models in the architectural practice, like, not just a traditional service firm, but something that's maybe a little bit more vertically integrated, or trying to produce something that's a little bit more like a product offering than it is like a service offering. I think we're starting to see that happen in the industry, and Hypar is a great place to sort of build the technical infrastructure for something like that, because of the sort of principles of automation and reuse and efficiency and all of this stuff that goes hand in hand with, a sort of product oriented offering. So that was a really long answer.
No, it definitely gives a lot of perspective, and I also feel like Hypar has a lot of potential, and you guys have put such a simple, intuitive interface for people to get on board into it. And, like, I could just imagine how much complexity it's going in the back end, and, like, software engineering problems here. So
yeah, I never get bored, I'll tell you that.
Yeah, and, like, you guys have a good vibe on, like, Twitter also. Like, everyone is, like, passing around fun comments and also sharing technical stuff, so it feels good.
Yeah, the team is incredible. I mean, I'm lucky enough to have only ever worked at companies that I really liked with people who were amazing. My whole career, I've never had a bad job, but this job is so good. Like, I can't even tell you how much fun we have, how incredible the team is, the way that ideas are discussed, and how fast things move, and how passionate everybody is, and how talented everybody is. It's just like, I mean, I'm in heaven. Like, it's an incredible place to work. It's an incredible team, and I'm so excited about what we're doing.
Yeah, and that brings a good segue to my next question. I wanted to know, like culture of Hypar, and also culture at WeWork, because I know I was talking to Levo, and he was saying, like, at one point, like, WeWork was the golden age where a lot of people like you, Daniel, and even Brian Wrigley, like, I just want to imagine, like, what was the vibe at that time?
Yeah, I mean, like, Lebo's spot on. I mean, it was an incredible time. It was just the density of really, really smart, interesting people doing really, really cool stuff all in one place. It was electric. It was really amazing. And, I think it's a shame that the kind of business oriented stuff started to go the way that it did, because I think the ideas were really critical. And I think also that the seed of that was really Case. Case was this design technology consultancy that was acquired by WeWork and became sort of the basis of WeWork's sort of BIM sort of expertise and excellence. And, that was always, when I was just starting out, I was like, oh man, Case is where all the like really, really cool people are. Like, I want to go be a part of that. And, when Case sort of got absorbed into WeWork, I think a lot of that went along with it. And WeWork was an incredible place. And I think specifically in this line of what I was talking about earlier about sort of a product-oriented mindset, the idea that space is a product and that there's room to do product iteration, to do A/B testing, to like think about these things through data and just continually improve space as a product is such a compelling and interesting idea. And I don't believe that like there was any flaw in that thinking. And I also see that a lot of folks who have left WeWork are now carrying on some of these ideas out in the industry, which is really cool to see. And yeah, I mean, I think I wouldn't be at Hypar if it hadn't been for the time I spent at WeWork and the learning that I did at WeWork. I had been writing a lot of plugins and stuff, but it wasn't really until WeWork that I was really doing like writing fully fledged software tools. I also give a lot of credit to Guy Tallarico, who I think a lot of people know, who was, a close collaborator of mine at WeWork and who taught me an immense amount. And so, it was really an incredible time. And then, as people started to peel off, it got a little bit less exciting and a little bit less fun. And, everything is a little bit scary when there are layoffs and when there are budget cuts and when everything seems to be kind of like slowing down a little bit. But, and to speak a little bit to the culture at Hypar, I think I give a lot of credit to Matt Campbell, our CTO, who he worked on the Revit team and also was at Google leading a team for a number of years. And he has crafted an engineering culture that I think is really superb. There is a tremendous amount of trust on our team. It is a very safe place to express ideas, even disagree with each other and argue. Sometimes that's the most fun. And we move really fast. It's a process where, I don't go off and develop a feature for 3 months and then come back and plop it in. We're constantly developing, releasing, iterating, improving, testing, figuring out what's working and what's not working. And we break stuff sometimes, and that's okay. I mean, it's, obviously we want to stop breaking stuff, but I've screwed things up even in production, and there's a culture also of no blame when it comes to these things. It's very, everybody just pitches in to get the thing fixed and figure out how we can avoid making the same mistake next time. And, the other thing is that, coming from a non-traditional software engineering background, I was trained as an architect. I always had a serious case of imposter syndrome in the area of any sort of software development stuff. It's like, I wasn't trained in this. I don't really know what I'm doing. And our team is like mostly former architects. In fact, I think only Matt has a CS background. And it's incredibly empowering to work on a team where like there's no expectation or penalty of knowing this obscure algorithm. Like, oh, you don't know how to do a bubble sort? Like, what are you doing? Like, none of that. I have never once been made to feel like I should have known something before. We just all learn together and we grow together and we build stuff together. And, when we need help, we have each other to rely on. I mean, the amount that I've learned just being a part of this team, it's like I would say like greater learning density than at any other time in my life. Like I'm I'm learning and feeling like I'm growing in my ability to do stuff like every single day, and it's just incredible. I mean, I'm gushing as I often do, but the culture is just like incredible. And I want, the other thing is that this is I'm gonna veer off on another tangent. I think that there's a lot more in common between the practice of software engineering and the practice of designing buildings than people realize. Some of that needs to be facilitated by technology, like Hypar, as well as other things. But I also think it's like it's a cultural thing, and it's a process thing, and it's about like mechanisms of collaboration. It's about, you know, every piece of code that I ever write is reviewed by somebody else. Somebody looks at it, somebody says, yeah, actually, I probably would change that, which is just like an immense safety net. It's like, you know, and, you know, if something goes wrong, it actually, like, two people messed up, not one. And I feel like design processes, like, there isn't really a great formal, at least on design teams that I've worked on, it's like there isn't really this sort of clear mechanism by which stuff gets sort of reviewed and continuously improved. And also this idea of sort of like the blameless postmortem, or like, it, you know, mistakes are the team's fault. They're not the fault of individuals. And so, you know, I think everybody deserves to love their job as much as I do. Everybody deserves to work on a team that has as like caring and dynamic and exciting a culture as ours does. And I think that like design practices can function like that. I'm sure some do. But I think that like it's also not a mistake that some of the technical infrastructure stuff like Git and being able to do pull requests and being able to sort of like establish these routines and processes which go hand in hand with the sort of cultural processes. Like, I think architecture maybe lacks some of the technologies to support those kinds of processes. And that's something we'd like to change as well. So big tangent.
I see. And like I could see that like the flexibility, productivity, and like growth at Hyper is quite visible. So like, how do you guys or like meet once in a week? Like, how is the growth and productivity
Yeah,
done? Like,
we meet 3 times a week regularly. So on Monday, we have kind of a all team meeting where we just go over everything we're all working on. And then Wednesdays and Fridays, we do a little check-in, and then other meetings kind of as needed. We have also like a weekly happy hour, as well as our little like public Hypar Live events, which are really fun. Shout out to Hypar Live. If you're watching this and want to hear more from our team, like go register for Hypar Live. We do it every couple of weeks. It hasn't been super regular lately, but it's always a good time. But a lot of our communication is via Slack. And, you know, we collaborate that way. We do a lot of pair programming. So we'll get 2 engineers together and, you know, work on stuff at once. There are some cool tools in Visual Studio Code that let you do this now. You can like share your live working session and like chat and stuff. And it's really cool. I also think like there's this, like, all of our processes are oriented around this idea of like maximizing impact. So, you know, we do quarterly planning and we try and figure out, you know, what we're trying to achieve and what sorts of growth numbers we're looking at, and everything sort of in a very neat way bubbles up to the question of like, what do we want to achieve? And how do we get there? And that just breaks down and down and down into individual tasks. So every day when I sit down at my desk, I'm, you know, maybe not explicitly, but I'm sort of asking myself the question, like, how can I have the most impact today? What can I do to create a feature that's going to drive people signing up? Or should I is it more worthwhile for me to, you know, do a tutorial or a live stream, or is it more worth it for me to work on a function? Should I be talking to users or should I be building stuff? And it's all answered. The answer to that question is always, well, like, what will have the most impact? Like what is going to make the most difference? And we always tie that to, how do we measure that impact? Like, what are the indicators of the impact we want to achieve? You know, is it sign-ons per day? Is it, how many people are using this function per hour? Like, how do we tie into this? How do we build instrumentation that lets us get feedback about whether something is working? And then how do we also change strategy when something isn't working? So we try really hard to like make a hypothesis. It actually is sort of very scientific. It could probably be more scientific, but make a hypothesis about a thing we're going to do, the impact we expect it to have, and a mechanism for finding out whether or not it's working. And then a date at which we'll say, okay, at this point, if it's working, then we keep doing it or we do more of it. And if it's not working, we try something else. And like, I think that has allowed us to just focus on what matters, because I think engineering teams, and I'm as guilty of this as anyone. And it's certainly, like when you get a bunch of engineers together, all you want to do is like build the cool feature. It's like, oh, I have this cool idea for a feature and I want to build a cool feature. And so maintaining this like impact-oriented mindset has been a real awakening for me. It's like, no, don't stop before you build the feature. And in fact, like, let's do a little bit of review collectively. Let's decide whether, let's figure out what we're trying to achieve by doing this feature. Let's figure out how we know whether or not this feature is having the desired effect. And that sounds like maybe extra work, but it winds up becoming second nature. And it just means that you wind up building the right stuff and also building stuff that's small instead of massive, because you want to do the smallest version of any given feature that will allow you to determine whether or not it's a good direction to continue pursuing, rather than building this massive thing that took 3 months and then finding out, oh, nobody really wanted that in the first place.
Yeah, and that's so great to have like clear vision and performance metrics, so that every day, and it feels like when a person is internally motivated, that itself drives to work like more and like get it done.
Yeah.
And you mentioned about like testing out features quickly instead of like a 3 months. Like, how is the brainstorming culture, and like are like people just, oh, let's do this.
Yeah, I mean, it's a combination. I think like for any medium size or larger feature, we'll do a design doc, and that can be pretty quick. If you're not familiar, I mean, I think every company does this a little differently, but basically it's like define what the problem is you're trying to solve, define a set of approaches. Like, just one answer to the question is not sufficient. You have to at least consider a few alternatives to how you might solve the same problem, share it with the team. Not everybody has to review and read every design doc, but everybody has an opportunity to, if they want to, or if they want to raise an issue. And then, you settle on a tactic and you deploy it. And then, for smaller stuff, sometimes as like a warm up in the mornings, I'll be like, what's been really annoying to me lately? The fact that like, I can't see whether or not one of my workflows is public on the main page. And so I'll just like, take an hour in the morning and build it and put it out there, and it goes. The other tactic that we use, which I think is sort of pretty common in a lot of sort of fast-moving software organizations, is rather than doing large feature branches, we do flag-guarded features. So we'll actually, all of the latest features are actually like already in production. It's just that you don't see them because we haven't flipped a flag that makes them available to you. But that way we ensure that there isn't some weird incompatibility between these two features. And so, that lets us do little experiments. Like, we can turn on the feature for half the people and see whether it causes any issues before we release it all the way. Or, we can have special beta testing user groups that have access to those features and things like that. So that also helps a lot with velocity and the viability of a feature. And a lot of times we'll build a feature, we'll put it behind a flag, and it will never get released. And sometimes that's okay. Maybe a new idea came along that was better than that one, and we don't need it anymore, and we'll just take it out of the code. But I think that's what, the risk of not having any process is it's the Wild West and you build the wrong thing. The risk of having too much process is that it's like kind of a slog to develop anything new. And it's like, I don't want to write another design doc. Like, are you kidding? Like, I just want to build the thing. And I think we've managed to, it's never perfect, but we've managed to strike a really good balance between like, just get it out there, test some stuff, but still making sure that people have a chance to review. We have we consider our alternatives before we like push a feature through just because we want to.
I see. And do you guys plan to work in person or remotely in the future?
I mean, I don't know. We joke about like, oh, when are we going to move into Hypar HQ? I really like the remote work lifestyle. So, I mean, COVID was no difference for most of us because like we were already on Zoom all day and already, working from our homes. I would love to, one day there may be some physical locations or there may not be, I think what we have is working really well. I think that like, I understand why the physical in-person office is a thing, and I don't think it's going away, although I think, obviously we're seeing some change in that. But, you know, I could see a future where that's never a thing for us. I could also see a future where, yeah, we get big enough that it would be better to have everybody in one place. But I think we're a couple years from having to make that decision at least. So,
Where is the headquarter located?
there isn't one.
Oh, I see. Okay. I have two questions left. One is, what frustrates you the most about AEC?
About AC. Okay. This is a good question. I think that there's a level of fear of trying new things, especially when it comes to software tools. People get very comfortable with like the 3 tools that they know, and they're very like scared to try other things, even if those things might like markedly improve their process. And I think part of that is also due to like the incentives being stacked wrong. I think that like, if you bill hourly, then having to bill fewer hours for the same project is maybe, I mean, theoretically it should allow you to do more projects, but like it doesn't always translate directly to like better outcomes. So, I think that really is a source of frustration, is that people are scared. But I also think that's sort of like, I could look at that as a frustration or as a, oh, architects are so set in their ways, or I could see that as a technical challenge to solve. Like, how do we make tools that are so powerful and so easy to use that people are happy to try them or integrate them into their process? So it's not all on the industry to solve that.
I see. And a lot of people in the audience are like computational designers who are interested in software development, and we see your journey. Like, what is some advice you would like to share with us?
I mean, I think there's just no substitute for like having a project and putting it out in the world. Like, I get so much joy from people using the plugins that I've written for Grasshopper, for, even, appreciating an answer that I gave on the Grasshopper forum or whatever, like just like sharing and being open about what you're working on pays incredible dividends. It certainly has for me. I mean, every job I've ever gotten is, like in some way indirectly from like, publishing stuff on Grasshopper, and I think that like, if you're in a work environment where maybe you are not able to share stuff publicly, or you feel like you don't have time for that, like I think having a project of your own, a pet project, is a really, really potent instrument to carve out space in the world and to make yourself more known, and to also make incredible connections. I mean, all the people I've had the opportunity to meet or interact with at conferences and stuff like that because of some of that early developer work. And let me tell you, those plugins are so, like, if you look at the code of those first plugins I wrote, it's so bad. Like, it's so bad. It's so embarrassing. Like, I wouldn't ever want anyone to see my source code. But, I made them to solve my own problems, and I shared them with the world, and I improved them when they broke. And there are still plenty of cases where they break. And that has really opened innumerable doors for me. And so, I think just like find a weekend project, find an opportunity to build some stuff that you think is useful and put it out in the world. And it worked, at least it has worked for me. Like, it's something that, has made me incredible friendships and professional connections, and given me all kinds of opportunities that I definitely wouldn't have had otherwise. And I also think it's the only way the industry moves forward. And I think that like a new generation of graduates who are more oriented towards this way of thinking about sharing and collaborating and not holding on to every 5-component script you wrote as like your firm's IP. That's the only way that the industry is going to move out of this trough we find ourselves in, where everybody's doing the same thing in parallel, stuck in the trenches, rebuilding stadium generators over and over again. I think but that move is not going to come from the top down. It has to come from the bottom up. Like, the people who are actually building the tools really have to be the champions of putting them out there. And I've been lucky enough to work for firms like NBBJ and Woods Bagot that let me open source some of the stuff that I was working on, even on company time. If you need to, work on a separate project in order to do that, like I encourage that as well. But yeah, I mean, I just think that like this, there's so much incredible work and knowledge going on, and libraries that people are developing and stuff like that. And just like, taking ownership over some small piece of that, contributing to an open source project, things like that are really, really a great way to go.
Yeah, that's a great piece of advice. One thing I always fear is when I do like short scripting, I do like a bit like hack around to get the code working. And when I try to publish on GitHub, like I question myself, will people understand or will they make mashup? So should I clean? And that procrastinates it.
Yeah. I mean, one of the things that I've learned in my time at Hypar, I think, is that like I had this is a big source of the like imposter syndrome stuff. I was convinced that like I was always writing horrible code because I never really learned. I never had, a CS education. And it turns out that like, yeah, there are some things you should probably pay attention to. You should use reasonable structures and try and keep your methods small. And there are lots of little things to do, but like, there is no golden standard of excellent code. There's only code that works and code that doesn't work. And, you can, you always want to move to like reduce tech debt and all of these other things. But like, there are some weird hacks in Hypar too. I've written hacky code. We all write hacky code every once in a while. You try to minimize it, and you also try to document it, and you always try and leave like a to-do to say like, okay, this is going to work for now, but in the future, we're going to want to consider ripping this out with something a little more robust. But like, I also think that like, one of the ways, like, it's a little paradoxical, but the only way to build confidence in that is by actually submitting it and getting feedback from people. And then that's the point of the pull request process on Git, is that like, if people think your code is too messy or you've done something wrong, then they tell you to fix it, and then you fix it. And like, that's an incredible way to learn, because you won't make that same mistake next time. And there's at least there should not be any judgment in pull request comments. I'm not looking at your code and saying, I'm just saying, okay, this is pretty good. This generally works, but like, let's just fix this other part because I'm worried it's going to have this downstream consequence or whatever. And so, that is how to learn. That is how to build that confidence. And I hear you too about it being a source of procrastination, but I would say like, don't submit a pull request that you're not happy with. But also, I also think this is an argument for starting small. And I mean, good development practices typically involve these like small changes anyway. So keep it as small as you possibly can so that you have time to maybe, clean up the syntax and the indentation or whatever before it gets submitted. And that's really all anyone will ask. So
I see. And yeah, I have seen your generative artwork. Are those two things in your background designed by you?
Yeah, they are. Those are both old Grasshopper pieces.
Awesome. Yeah, and I would like to end this session. And thanks a lot, Andrew. Like, it was very inspiring, and I will rewatch it a few times because there's a lot of important stuff you shared with us. And thanks a lot for being so honest to share like the culture and insights about your journey. It really helps us to know like what were the things you went through. And
well, thank you so much for having me. It's been a real pleasure. And I think what you're doing, what you're putting out into the world by organizing this stuff and by asking those questions and, connecting people with this world. I think it's I'm really excited to see where it goes for you and for the industry, because I think it's going to be, it's already a huge resource, and I only see it growing. So I'm really excited for you, and really grateful to have had the opportunity to speak with you and with your audience today.
Thank you. Have a nice rest of your day. Bye-bye.
Thanks. Yeah, you too. Thanks everyone for watching.